Okay, so the topic is L'Hopital's rule. So we are going to study some special technique to find the limit of some complicated expression, especially some fractional expression. So let us start with some quick examples. So the example A is quite interesting in a sense that if you plug in x equals 0, we have, well, e to the 0 minus 1 over 0. Well, this gives you 0 over 0 form. So it's quite difficult to find a limit directly. Example B is also quite interesting. Well, when x tends to infinity, ln x will give you infinity. And x, of course, will give you infinity. So this limit is kind of indeterminate. So we will discuss nice tool to find limits of those types. So those limits are called indeterminate form of type 0 over 0 and infinity over infinity, respectively. So L'Hopital's rule is very useful when we compute limit of those types. So this theorem is named after French mathematician L'Hopital. So the theorem says that suppose we have fx over gx, which evaluates to either plus minus infinity or infinity over infinity or 0 over 0, then the limit becomes simply limit of f prime over g prime. So the limit of original expression becomes limit of f prime over g prime. Well, what we expect is when we take derivatives, we expect those functions to become simpler, and then eventually we want to simplify or reduce this expression and find the limit. So let us apply this method to our previous examples. So as the theorem says, this expression is of 0 over 0 form, so we can apply this theorem. When you plug in 0, we have 0 over 0. So L'Hopital's rule says that this limit becomes a limit of derivative of numerator and derivative of denominator, which is 1. And then now you see this resulting expression is always simpler than previous, and we are ready to plug it. Well, x equals 0 will give you 1 over 1, which is 1. So this is how to apply the theorem. Similar for the second one. So now that we have infinity over infinity form, we take derivative of those two functions. So derivative of ln is 1 over x, and then derivative of x is 1. Now x tends to infinity. This expression gives you 1 over infinity or 0. So let us continue to discuss more examples. So in the first example, when you plug in 0, we have e to the 0 minus 1 minus 0 over 0. Again, 0 over 0 form. So basically, we have 0 over 0 form. So we are ready to apply L'Hopital's rule. So when you take derivatives, this numerator becomes 5 e to the 5x. And then this one will be gone, and then negative 5 over. And the denominator is simply 2x. And now our x tends to 0. Again, when you plug in 0, we have 5 minus 5 over 0. Again, we have 0 over 0 form. So we are ready to apply the L'Hopital's rule again. So limit. When you take derivative further, we have 25 e to the 5x. And this number 5 will be gone. And so we have 2. And we are ready to plug in this number to get the limit. Well, 25 over 2 is the limit. When you write down your solution, it's a good idea to indicate which theorem you are using. So you simply put L'Hopital's rule to say those inequalities are based on L'Hopital's rule. Okay, number 2. Well, again, we have infinity over infinity form. So we are in good position to apply L'Hopital's rule. So applying L'Hopital's rule, we take derivative of both functions. Well, this is composition, so you need to apply the chain rule as well. Derivative of this guy is 1 over inside function, and then derivative of inside function. And then again, derivative of 1 is simply 1. Okay, so, well, this unbounded value will give you 1 over unbounded value times 1 over unbounded value. So you can find the limit, basically 0. Number 3, well, we have arctangent here. Eventually, you want to take derivative of arctangent. Here is a quick review. Arctangent has derivative 1 over 1 plus x squared. So you want to apply this derivative of arctangent. When you plug in 0, we have 0 over a 0 form again. This is indeterminate form. So you apply the L'Hopital's rule. Numerator is quite simple because it's just 1. For the denominator, you apply this formula, 1 over 1 plus square of inside function, and then derivative of inside function. Okay, and we are ready to plug in. So x equals 0 will give you 1 over 1 plus 0 times 2. So this is 1 over 2 over 1, which is 1/2.